Okay, today we're looking at factors and prime factorization. Most of this will be a review for you. There'll be a few things that we look at the very end that are very easy, but something you haven't quite seen before. So let's look at these definitions. With this chapter, it helps to know your definitions. If you don't know your definitions, when you take the test, you're going to be very confused on the test. So let's look at the word factor. Formal definition: a number or algebraic expression that divides another number or expression evenly. In other words, 2 goes into 4 evenly, so 2 is a factor of 4. 4 goes into 16 evenly, so 4 is a factor of 16. If a number divides evenly into another number, it is a factor of that number, okay? Pretty easy stuff. Prime number, it's a whole number greater than 1 with exactly 2 factors. 2 whole number factors, 1 in itself. So 3 is prime because it's only 2 factors. The only 2 numbers that go into it evenly are 1 and 3. 5 is prime because the only 2 numbers that go into it evenly are 1 and 5. Composite number is basically a number that's not prime. It's a number greater than 1 with more than 2 whole number factors. So 4 has 1 and 4, and then 2. So 4 actually has 3 factors, so it's a composite number. Prime factorization, that's writing a number as the product of prime numbers. You've done that before, but it just helps to know the definition. Okay. So when we're writing factors of a number, we're going to look at this. We're going to look at 30, and I call this a T-chart. And we basically use the T-chart to write factors. So I'm just going to write the pairs of numbers that multiply to be 30. Well, we start with 1. 1 times 30 is 30. Well, 2 goes into it, and that's 2 times 15. 3 goes into it 10 times. 4 doesn't. 5 goes into it 6 times. Now, I stop here because if I go one more, I'm at 6, and I've already got 6 written down. So once I see that I'm going to start repeating numbers I've already got in this chart, I stop it. So 30 has 2, 4, 6, 8 factors. Okay, look at 31. Let's write the factors of 31. Well, 1 and 31 are factors, but since 31 is prime, that's it. That's all we can write. So 1 and 31. Let's look at 45. Do a T-chart. Okay, it's an odd number. 2 doesn't go into it. 3 does 3. Well, 5 plus 4 is 9. 3 goes into 9, so 3 goes into 45, and that's 15 times. 4 doesn't. 5 does 9 times. 6 doesn't. 7 doesn't. 8 doesn't. 9. We're already starting back with what we have in the chart. So this has 4 factors: 3 and 15, 5 and 9. 87. Well, if we look at that, I know 1 and 87. Always 1 in the number itself. Is this a prime number? Is there a number that goes into it? Can you think of a number that goes into 87? If not, it is prime. Let's see. 7 and 8 give me 15, right? And 3 goes into 15, so 3 goes into 87. And I believe 3 goes into 87 29 times. Okay, again, I added these together. 8 plus 7 is 15. So 15 is divisible by 3, so 87 is divisible by 3, and that's 29 times. So that has 4 factors. Moving on. Tell whether the number is prime or composite. Well, this one has to be composite because it's an even number. So I know 2 goes into it. 147. Let's add the numbers together. 4 plus 1 is 5. 5 plus 7 is 12. 12 is divisible by 3, so this is divisible by 3. It's composite. 91. I believe 7 is one of those weird numbers you just have to try. 7 goes into 9 one time, remainder 2. 7 goes into 21 3 times. So 7 goes into that, so it is composite. 381. Add the numbers together. 8 plus 1 is 9. 9 plus 3 is 12. It is divisible by 3, so it's composite. This is an even number. It's composite. 29 is a prime number. We should know that. 97. 97 is a prime number. Okay, and 2035, well, it ends in a 5, so I know 5 divides into it, so it is a composite. Okay, so primes and composites. Write the prime factorization. Okay, what we're going to do is upside down division. So let's look at 72. What's the smallest prime number that goes into 72? Well, 2. That's 36 times. Okay, again, divide again. 2 into 36. 18. I keep going with 2 until I can't anymore. Now I'm down to 9. What's the next largest? Yeah, 3. Next smallest prime number is 3. 3 goes into 3 times, and I keep going until I get a 1 at the very bottom. 3 goes into 3 one time. So these are my factors right here. I didn't circle the 3 very well. So there's 3 2's and 2 3's, so it's 2 to the third times 3 to the second, and that's prime factorization. Okay, it's writing a number as a product of primes. Let's look at this one. 400. Well, 2 goes into 400, 200 times. 2 goes into 200, 100 times. 2 goes in 150 times, and I can keep going with 2 until I can't anymore. Okay, now I'm done with 2. I got 5 goes in there 5 times, and then 5 goes into 5 one time. I'm done. These are my factors. I got 4 2's, and I got 2 5's. And I'm always multiplying because they're factors. Okay, so 2 to the 4th times 5 squared. Let's look at 96. 2 into 96. Okay, that's going to be 48. 2 into 48, 24. Keep going with 2 until it doesn't work anymore. 2 into 12, 6. 2 into 6, 3. 3 into 3, 1. How many 2's do I have? 1, 2, 3. 2 to the 5th times 3. Next one, 244. Divide. That's 122. Divide again. 61. 61 is prime. Okay, so my prime factorization is 2 squared times 61. Okay, this looks weird because 61 is a larger number, but it is prime, so it works. Next, factor the monomial. Okay, this is different, but it's pretty simple. It's pretty basic to what we've seen before. First, I want to factor the number 12. So let's prime factor 12. 2 goes into that 6 times. 2 goes into that 3 times. 3 goes into that 1 time. So I get 2 squared times 3. Now, to factor these, again, think of A. What are the factors of A? Well, 1 and A. That's what multiplies to be A. So it is technically, you kind of think of it, even though it's a variable, think of it as a prime. So it'd be just times A times B times C. Basically, all I did was put multiplication signs between the 3. Okay? And that's pretty simple. Look at the next one. 29 is prime, so I don't have to really factor that. Now, x squared, I want to just expand that. Instead of x squared, I'm going to write x times x, because those are the factors of x squared. Then y fourth is just times y times y times y times y. So I should have 4 y's, 2 x's, and a 29. 45, let's factor that one. That's 5, 9, 3, 3, 3, and 1. So it's 3 squared times 5. Now I've got z to the 5th times z times z times z times z times z. That is factored. One more. Let's factor 18, 2 and 9, 3 and 3, 3 and 1. Okay, that's 2 times 3 squared. I've got 3 x's times x times x times x, and 2 y's times y times y. And I'm finished. That's how you factor a monomial. Again, a monomial, keyword here is mono, which means, or mono means 1. Okay? This is one, it just means a single term. So this is an expression with a single term, whereas a binomial would have 2 terms. The prefix bi means 2, and then we also have trinomials, which means 3 terms. Well, this is just a single term expression, so they call it a monomial. Okay, that's all you have to know about monomials. One more thing. Let's look at a word problem. Length of a rectangle is 3 feet more than twice its, my line's terrible, width. If the width of this garden is given by W, so basically you have a rectangle here. Bad rectangle, sorry. Let me kind of redo some of this, okay? We have a rectangle here, and I'm just sketching. The width is given by W. Well, the length is L, okay? Width and length. Now it says write an expression in terms of W for the length, meaning instead of L, we want to write something that has a W in it. So what does L equal? Well, we're told what L equals up here. Length is, that means length equals. L equals what? 3 feet more than twice its width. What is 3 more in mathematical terms? Well, that's 3 plus. Twice its width is just 2 times the width, which is 2W. So the length is the same as 3 plus 2W. This is in terms of W now. That is writing the length in terms of W because I have a W as a variable. Write an expression for the perimeter in terms of W, meaning I don't want an L in there, I want a W. So here's a W, here's 3 plus 2W. So the expression for the perimeter, I'm just going to add all the sides up. 2W plus 2W plus 1W plus 1W is 6W. Then 3 plus 3 is 6. I just added like terms. And in this part, part C, it's going to equal 114. Okay, so we said, let me do that over. So we're going to subtract 6 from both sides, and I get 108. Then I'm going to divide by 6. That's going to equal, let's see, 18. So W equals 18. So if W equals 18, then the length is 2 times 18 plus 3, which is 39. And that is a basic geometric word problem.